All right, welcome back. This is video number 3. I was looking to see if I could see. I think his name's Ted Klott. I think that's his name, who does the solutions to a lot of the Brian Passwater work. And I was looking to see if he was like doing all this work to simplify to an answer, and the answer is yes. So I guess in this, because it was specifically, and again, read what it's asking for. They're specifically asking for any relative extrema. That means they're looking for the y values. That means we are going to have to find out what the function value is by plugging in the x value where we know it happens to figure out the y value that it actually achieves, right? And so I went ahead and did that in pre-recording here. I went ahead and plugged in the -2 into the function in order to get my y value, and here's my y value. Oh, I think I did something wrong. There you go. So here's my y value, -25 thirds. So that's what I'm going to write here, -25 thirds. So the relative minimum of f of x is -25 thirds, and it happens at x equals -2. And I know that's true because the derivative change signs from negative to positive. When we look at example number 3, we're going to do the same thing, but we are already lucked out because they found the derivative for us. So when we go to step 1, take the derivative. Well, they already did the derivative for us. So now the next thing is, can we find the critical values? So there are critical values. The critical values occur, let's zoom in a little bit here. The critical values occur at x equals 0, x equals -4, and x equals +5. How do I know that? Because there are 3 factors. And so I set each factor equal to 0, either literally on paper or in my head, right? What makes this equal to 0? Or if x was 0. What makes this equal to 0? Oh, if x equals -4. What makes this equal to 0? Oh, if x equals +5. Those are my 3 critical points. And so now knowing that, we can start our, or maybe we can't. We can start our, what happened to my pen? Oh, there it is. We can start our sign chart for x values at -4, 0, and 5. By the way, I've had students in the past get really like into the process that they sometimes forget. Just because I found these numbers in this order doesn't mean that's the order I put them into the number line, right? I have to put them in numerical order. -4 comes before 0, which comes before 5. So make sure to put them in the right place. Otherwise, it's going to mess up your sign chart. We want to find g prime values. Well, these x values were special because the derivative was equal to 0. The derivative of g was equal to 0 there. Now we're going to test values. So let's test a value over here, like 6. So if I substitute 6 into this. Now, one thing to point out, this term is squared. So it doesn't matter what number I substitute into that 3x squared, it's always going to be positive. So from now on, I'm not even going to check that because I know that my answer is always going to be positive, and I really just need to check the other two. If I substitute 6 into the second term, a second factor, I'm going to get a positive. Oh, I'm going to get a positive. And if I plug 6 into the last term, I'm going to get a positive, and a positive times a positive is a positive. Great. And if I were to have multiplied it times the pink box, it would have been positive still. Pick a number between 0 and 5. I like to pick small numbers, easy numbers like 1. So 1 plus 4, that's positive 5. 1 minus 5, that's negative 4. I don't really care about this one, but if you multiply negative times positive, you're going to get negative. Pick another point in between -4 and 0, like -2. So -2 plus 4, that's positive. -2, that's negative. And a negative times a positive is a negative, so this is negative. And then we'll pick a point on the left side of -4, like -5. -5 minus 5, that's a -10. -5 plus 4, that's a -1. Negative times a negative is a positive, and so I have a positive. Great. What does this tell me? This tells me that the original function, let's call this g, was increasing, then decreasing, then still decreasing, then increasing. Do you see any peaks or valleys? Well, yes, there's a peak here, so the relative maximum is going to be at -4. There's a valley over here, there's a dip, so that means the relative minimum is going to be at 5. But at 0, there is none. By the way, if you read the directions, we had two jobs. Number one, we had to find where the function g is increasing or decreasing. So let's say g is decreasing for x's that are between -4 and 5. So -4 less than or equal to x less than or equal to 5. It's going down, so we include everything. And g is increasing for x's that are less than -4, less than or equal to -4, I should say, or x's that are greater than or equal to 5. Right? Okay. But now we're the relative extrema. And notice the phrasing of this part. Find the location of any relative extrema. So they're not asking us for the y value where we have to plug in like we did last time. Now they just want to know where does it occur, what x value. So we're going to say g has a relative, let's spell out the whole word, relative maximum at x equals -4 because g prime changes from positive to negative. And g has a relative minimum at x equals 5 because g prime changes from negative to positive. Right? If it's going from negative to positive, there's a dip, and therefore that's a relative minimum. They never asked me what it is. They didn't ask me, find the relative extrema. They said, find the location of the relative extrema. So that's what we did here when we said at x equals -4, at x equals 5. And that's it. That's example number 3. If you, again, understand the process of finding intervals of increasing, decreasing, the first derivative test for relative extrema is really just using that idea and the sign chart to kind of help us find those hills and valleys. We'll come back. We'll do one with a graph, and then we'll pause.